this lab, we try to build a mathematical theory of how the human brain works, and specifically how humans see. So there are two misconceptions about seeing. The first is that seeing happens only with the eyes, and that when you go to see an eye doctor, they measure your eyes, and that's all there is to it. That's actually wrong. A lot of the seeing happens in your brain. So in fact, when you see, the information goes to the back of your head, to your brain, and from there to other parts of the brain. The second misconception is once you open your eyes and you receive information, that's all there is to it. That's also completely false. Actually, seeing is a very active process, and there's a lot of information from the brain down to your eye that are important for seeing.
Well, to study vision and to study visual perception, we need to do experiments on human observers. And for example, here we're interested in the perception of transparencies. Or for example, imagine that you have in a day, a foggy day. There's fog between you and the buildings, but you can still see through it, no? And to do experiments, we need to have a way of replicating this in the lab. For that, we cannot wait until the day is foggy, but we simulate it with this kind of devices that I will show you later. So for example, let's take you probably know this illusion, which is a line length illusion. So these two lines have the same length. But if I draw arrows on the sides, you'll see that one looks longer than the other. And we want them to answer which one is longer. And there's no point that they come with a ruler and then they measure with a ruler this, because this is not what we are interested. We're interested in how they look like.
I would say that the biggest and most important problem in our field is getting the right question and getting the right experiment to answer that question. So of course this is important in all areas of science, but in our area it's especially important because biology is messy and it's complicated. And so we want to be able to narrow down what we're studying to something clean and simple so that we can study it in the lab. But at the same time, if something is too narrow and too clean, then it's an artificial stimulus, and that does not apply to the things that we see out in the real world. So it's a real challenge to come up with the right balance between the two extremes. I studied computer science and psychology throughout my degrees.
In my background, I also studied, so I studied medicine first, and then I did neuroscience. And I did my PhD here in the TU in computational neuroscience. Okay, so to study transparency and fog and our perception of it, we can simulate it here in the lab using this device. So this is a motor that will spin, and I can put this background that is a checkerboard that has white and black checks, and I put a disc on top that will rotate. Now if we turn on the motor, you see that it rotates. That's not really much interesting, but if we speed it up, what do you see now? You see that now you cannot distinguish the disc rotating, but you see transparency. You see that this disc is as if it would be a piece of glass that is transparent, and you can see through it. So now let's see this other example. We have the two motors now. The background is the same, and you see that the opening is also the same. But the difference, we have two discs. One is black and the other is white. And now if we run both of them, what do you see? Do you see a difference? This looks more transparent than the light one. So you see more through for the black one than for the light one. What happens if we change the backgrounds? So now we have a background that is the same, but it has less, it's dimmer than the previous one. The discs are the same. And what happens now? Do you notice a difference? Well, most people will say that this still people can see through it, so you can see through this disc on the left, but on the right, you cannot see it through anymore. And it looks like as if it would be opaque and solid. What does this mean? This means that our perception of transparency doesn't depend only on the disk. It also depends on the background, because by changing the background, it changes our perception of how transparent things are.
Okay, so the second misconception is that seeing is like recording with a camera, that you just open your eyes and you automatically receive information about the world, kind of like a camera recording a video. But it's actually much more active than that. So here, do you remember #thedress, which went viral on the internet a few years ago? So some people see this picture as being of a dress that is blue and black, and other people see it as a dress that is white and gold. But the image is exactly the same for everybody. So it's actually about how each person's brain interprets the image that results in a completely different perception. So that's what we do here. As scientists, our job is to take this subjective impression of seeing and turn it into something that is concrete and objective that we can understand and measure. Also, we are at the TU, and that means we are interested in developing mathematical equations, or models as we call them, that can explain how the human brain works.